Hello everyone. So today we are going to learn a new data structure known as hash table. Hash table is a very important data structure, and the hash table, the main purpose of hash table is also searching a item efficiently. Okay, hash table is the data structure and the implementation of the hash table is known as hashing. Hashing is actually a technique or algorithm. Hashing is a technique or algorithm we use to perform insertion, deletion, and finding a item in the hash table at a constant average time. All right. So far we learned about a lot of data structure, and in many data structure we analyze the performance of searching operation. So far we know that, like, we know different searching operation, and in many of the data structure, for example, in linked list or array. All right, if the data is in random order, the searching generally takes order of n. Okay, so consider the very simple data structure like array. Okay, if the data is in random order, searching takes order of n. But if the data is in sorted order, in that case we can implement the binary search. Okay, in that case the searching is efficient than linear time. This is order of log n. Okay, now what we want. Okay, so what we want, we want to find the item, we want to search an item. In average case we want the runtime to be a constant runtime. Okay, in that case we can use hash table and using the hashing technique. The worst case runtime can be order of n, but the constant average, average runtime, it is constant in hash table. Okay, but the main purpose of the hash table, we want to the main purpose of the hash table, that we want to search an item in average time in constant runtime. But there are certain operation which is not actually very efficient in hash table. For example, if a operation requires any kind of ordering, for example finding the minimum, finding the maximum, or printing the entire table in sorted order, in that case actually hash table doesn't help us anyway to find the items in any ordering in a efficient runtime. The only purpose of hashing is that the hash table is that the searching of an item and insertion and deletion also, for these three operation, the average case runtime is constant. Okay, the general idea of hash table is a hash table. The hash table itself is the data structure. Okay, the hash table has a fixed size. Hash table is an array of some fixed size. Okay, all right. The stored item we are going to store in the hash table, the item we are going to store in the hash table is known as key. Okay, known as key. So, and this key will be also used to computing the index value for an item. Okay, the key that we are looking for, the key that will be inserted in the hash table, or that is the member of the data member of the hash table, they could be integer or a string. Okay, for example, like if you have a large employee data structure, the key item could be a name or id of that data structure, of that employee table or employee structure. Okay, the size of the array or hash table is known as table size. Okay, I mean the hash table, it has a fixed size. The items that are stored in the hash table, it is going to be indexed by values from 0 to table size minus 1. So obviously the hash table itself, it's a table, means it's actually a fixed size array. All right, a fixed size array, and the item we are going to store here, we are going to store from index 0 to table size -1. Okay, the index starts from 0 and the last index would be the size of the table, okay, -1. All right, now each key will be mapped into some number range from 0 to table size -1. This number is known as hash value. So each of the value here, each of the item here is going to be mapped to a number which will be also range from 0 to table size -1. Okay, and this number is known as hash value. And this is the main idea of hashing, is actually finding the hash value, and using the hash value is going to help us to find the item. We're going to find the item using the hash value, and average case runtime is going to be constant. Okay, and the mapping is known as hash function. Okay, so the main idea is that the data structure is the hash table. Okay, and we are going to store each of the item, we are going to store the items in the hash table, but for each item we want to calculate a hash value. Okay, using the hash value we can easily find out the item from the hash table. Okay, and average case runtime will be constant. Now how we are going to calculate this hash value? Using a hash function. Okay, so let's see an example, a very simple example. Okay, now let's say the very simple hash function is h of x equals to x. Okay, so that means if the value is 8, okay, h of 8 will be 8. If the value, the key item that we are looking for, the key item here is x, the key value is x. Okay, so if the key value is 10, the h function, the hash value will be 10. So this is our hash function. Okay, so this is our very basic hash function. We are going to talk about different type of hash function and we are going to analyze them. All right, so using this hash function is going to calculate the hash value. So that means our key value is, if our key value is x, hash function, this is our hash function, and the hash value is the result of the hash function. Okay, now if h of x equals to x, that means our function is h of x and the hash value will be also x. So if our key value is 8, our hash function will create hash value 8. If our key value is 10, our hash function is going to create a hash value 10. Okay, all right, so this hash value is nothing, just the index of the array where we are going to store the value. For example, let's say these are our key value. Okay, these are our key values, we want to store them in the hash table. Okay, hash table is a fixed size of array, and here the size of the array is, you can see, 14. Okay, size of the array here is 14. All right, so let's say our first key value is 8, so we are using the hash function and this will give us the value 8. Okay, 8 value of key value 8 is 8, so we are going to store 8 in the index 8 itself. All right, so 3, the hash value, hash of 3, it is 3, so we are going to store 3 in the index 3. 13, we are going to, h of 13 is 13, so we are going to store the 13 in the index 13. So 6, we are going to store it in 6. 4 in 4. 10 in the index 10. Okay, now let's see how we are going to find a item, how we are going to search for a item, and what will be the runtime. Let's see the key value I am looking for is 4. Okay, so the item I am looking for is 4. So what I am going to do, I am going to use the hash function. I am going to calculate the hash function for 4. This will give me the value 4. So I know that I can find the item in the index 4. Okay, so I look for the item in the index 4. If the value is here, the item 4 will be in that index. Okay, now let's say I'm looking for item 5. Okay, now I'll calculate h of 5, which is 5. Now I'm going to find the item in the index 5. So looks like there is no value. That means 5 is not found. Okay, 5 is not in our key space. Okay, so what is the runtime? So the runtime here is order of 1. So I'm going to calculate the hash value, and this is actually the index. The hash value is the index where the hash value is the index of the value. Okay, so I'm going to calculate the hash value, and I'm going to look the item in the index which is my hash value. Okay, so the runtime is order of 1. All right, now what is the problem here for this hash function? Let's say the item, I have a new item 50. I want to insert the item 50 in the hash table. Okay, so what will be the hash value for 50? Will be 50. Okay, so that means I have to increase the size of the hash table, and I have to increase the size of the hash table, and in the index 50 I have to insert the item 50. Okay, and all other space here from 14 to 49. Okay, from 14 to 49 all other space here actually will remain unused. And what happens if I have a value 1000? Okay, this is a digester, right? So that means I have to increase the size of the hash table, and here lot of the space in the hash table may stay unused. Okay, this is a lot of wastage of memory space. All right, so hash function, there are a couple of requirements for the hash function. So the hash function should be simple to compute. So looks like the hash function we are talking about, this is really simple to compute. Okay, the hash function should distribute the keys evenly among the cell. So this is one requirement. This is couple of expected requirement for the hash function. So it should distribute the keys evenly among the cell. Okay, now from this hash function we can see that this doesn't distribute the keys among the cell. Okay, so here we have couple of items, then we have one item in the index 50 and another item in the index, if we have a value 1000, another item will be in the index 1000. So this doesn't actually distribute the keys evenly. Okay, the keys may not be numeric. All right, it doesn't require that keys is always going to be numeric. The value we are storing here 1 2 3 4, but we may want to store like string also. Okay, for example, some name of the employee, ID of the employee, or some other information. Okay, so the keys may not be numeric. Number of possible keys is much larger than the space available in table. So number of possible keys can be larger than the space available in the table. So here if we have a fixed size of table, okay, so for example, let's say we have a hash table of size 10, but the number of keys could be much more higher than that. Okay, we have to take care of that. So different keys may map to same location, and in that case it is going to create a collision. Now there are different type of hash function. Few hash function is known as one-to-one. Okay, if the hash function is 1 to 1, it is not going to create any collision. It means that for each different value, okay, for each different value, hash value will be different. Okay, for two different key x1 and x2, this is not going to map to the same hash value if the function is 1 to 1, but the function could be also many to 1. Okay, or many to many. Many to 1 means if we have two different key value, this could lead, okay, this could create one hash value. Okay, this is many to 1. This can create a collision. We're going to see one example. Okay, so let's use another hash function and let's see whether this creates a problem. Okay, so we saw that this simple hash function has a problem because using this hash function, it doesn't evenly distribute the value in the hash table, and also the hash table size may have to be very large than the number of key values. Okay, now let's use a different hash function. Okay, let's use a different hash function. H of x equals to x mod table size. Let's say we are going to have a hash table of fixed size, and the size here we are using the size equals to 10. So here the hash function will be x mod 10. Okay, so here the index will be 0 1 2 3 4 5 6 7 8 9. Okay, and let's see now we are going to use the same key value 8 3 13 6 4 10. Okay, so 8 3 13 6 4 10, let's see 50. Okay, and let's see 1000. All right, now our hash function is x mod 10. 10 is the size of table. Okay, so now let's insert 8. 8 mod 10 equals to 8, so we're going to insert 8 in here. Okay, so 3 mod 10 is 3, we're going to insert it here. So 13 mod 10 equals to 3. Okay, so that means 13, I should insert it here. So what happens, there is already a value. Okay, so here if the hash function is not 1 to 1, it is going to create a collision. Okay, so it is going to create a collision. Collision means if two different key value x1 and x2, where x1 is not equals to x2, okay, two different key value create the same hash value. All right, if the two different key value created the same hash value, that is known as collision. Okay, that means we are trying to insert the two different key value in the same location, but we can do that. Okay, that creates a collision. All right, so we are trying to solve the problem here. All right, but here this creates another problem which is known as collision. Now we have to actually know some technique to resolve the collision. Okay, all right, so let's see what happens for the other value. So 6 we can insert 6 here. 4, we're going to insert 4 here. 10, we're going to insert 10 here. What about 50? 50 more 10 is also 0, another collision. Okay, 1000, another collision. All right. So so if there are too many collisions, the performance of the hash table is not going to be exactly order of 1. It is going to be more than order of 1. Okay, it can suffer than the constant runtime, but now we are going to see different type of collision resolution, and this is very important topic in knowing about the data structure of hash table. Okay, so in the next segment we are going to know about collision resolution.